problem number 5, we want to simplify each fractional expression here. The key is to make sure that the top and the bottom are in a factored format because I can only divide out common factors. When I look at part A, that's exactly what I see. The top has been factored. It's one big multiplication problem. The bottom is factored. It's x times x times x. So if I see any common factors, I can divide them out. And of course, what I see is x squared here, dividing out 2 of those x's. And that's it. 5x minus 1 is its own factor. I don't have one of those on the bottom, so it will stay put. My final answer here is 5x minus 1 over x. I cannot go any further because 5x and 1 are not factors. They're part of a subtraction problem. And so this is the final answer. Letter B, I am not looking at a factored problem, at least on the top. The bottom is 4 times x. That's great. The top is a big subtraction problem, so I will try to factor it. First step of factoring is pull out the GCF. There is an x that's in common to both of those pieces, so I will pull it out to the front and fill in what's left. Now you might remember from algebra that x squared minus 4 actually continues to factor. It's called a difference of squares. It factors x plus 2, x minus 2. I could do that, I just don't think it's going to help me. The reason I'm factoring is to look for common factors, and I'm not going to find anything dealing with x plus 2 or x minus 2. So I think I've factored sufficiently to look for common factors. Of course, I have a common factor of x on the top and bottom. Those are the only common factors I'm going to find. And so my final answer is x squared minus 4 up top, and then 4 on the bottom. Again, that top 4 is not a factor, so it is not eligible to divide out with the bottom 4. Part C, everything's factored already, so I can just look for common factors. I do see that single x is going to divide out one of those. And then I have an x plus 2 on the top. I have a couple of x plus 2's on the bottom, so the 1 on the top can divide out, leaving me with one of the 2 that I previously had on the bottom. What do I have now? I ended up with an x on the top, and the only thing I've got on the bottom is the x plus 2. Since it's the only one left, I don't need the parentheses anymore. The x on the top is its own factor. The x on the bottom is not a factor. It's part of an addition problem, so I don't have anything else I can divide out. Letter D, I'm going to have to do some factoring. X plus 5 doesn't factor, so I'll put it in parentheses to remind myself it's its own factor then. The top, though, I can pull out a 2. I see that I have a GCF there, so 2 parentheses x plus 5 over the x plus 5 factor I had on the bottom. Obviously, I've got this common x plus 5 factor here. This one simplifies so much that I don't even have a fraction. I just end up with 2 over 1, which is equal to 2. Let's see, finally, letter E. Now this is a tricky one. It sort of looks like the top is factored, but it is not. This is a giant addition problem, which means that parentheses there is not helping me at all. I'm going to need to rid myself of that by foiling out x plus 3 times x plus 3. And then maybe after that I can do some factoring. I do see on the bottom I have a GCF of 3 that I can pull out. If you're looking at these x plus 3's we have in common, again, I don't have any canceling I can do at the moment because of this plus. Let's go ahead and do the foiling. Let's see, I'll have x squared. The outer and the inner will be 3x's, so that'll make 6x. And then the last will be 9. Again, that bottom is just sort of staying there waiting to see what happens later. On the top, the x squared terms do subtract out. Negative x squared plus x squared, that's just 0. So now I have 6x plus 9 over 3 times x plus 3. Finally now, I can try to factor the top. I do have a common factor, let's see, it looks like of 3 that goes into both 6 and 9, so that's going to leave me with 2x and 3 in here, keeping that bottom the same. Okay, everything is now fully factored. The only common factor I have is that 3 sitting on the outside. I don't have any 2x plus 3's on the bottom, and I don't have any x plus 3's on the top, which means this then is the final answer. 2x plus 3 divided by x plus 3. All of these pieces are not factors. X is part of an addition problem. 3 is part of an addition problem, etc. So there is nothing else I can do. This is the final answer. In problem number 6, we want to rewrite each trig expression in the simplest way possible. Letter A, 1 plus tangent squared x. When I see a 1 and a trig function squared, I immediately think one of the Pythagorean identities. Of course, the main Pythagorean identity is sine squared plus cosine squared equals 1, which is the one that has a tangent in it. That's the one that you could obtain by dividing every single piece here by cosine squared x. I know that because sine over cosine is tangent. The first term would become tangent squared x. The second term would be a 1. And the final one, 1 over cosine squared, would be secant squared x. Well, see, that's exactly the one I need. I'm just trying to replace 1 plus tangent squared x. According to this identity, this is just equal to secant squared x. Letter B is very simple. I have sine x times sine squared x. Sine squared x just means sine x times sine x. So I have 3 of them in all being multiplied here, which means this is equal to sine cubed x. Letter C, I have sine x times cotangent x. What I'm thinking about here is that cotangent x can be replaced using that quotient identity, which is cosine x over sine x. And that works out very nicely because now I have some cross-canceling I can do here. And the only thing I have left is just cosine x. And that would be the final simplified answer. Letter D, again, a trig function squared on a 1 makes me think about Pythagorean identities. Here's that main version of the Pythagorean identity again. Can I somehow make a cosine squared x minus 1? It looks like I'd have to do a couple of things. I'd have to move the 1 over to this side, and then I'd have to move the sine squared x over to that side. If I did those two things, I'd have cosine squared x minus 1 on the left, and I'd have negative sine squared x on the right. Well, this tells me what the answer is. I was looking for another expression for cosine squared x minus 1. According to what we just figured out, this is equal to negative sine squared x. Letter E, I just need to divide out the common factors. Everything is all in factored form. With the numbers, 2 goes into 6 3 times. And with the cosine x's, I have 4 of them up top and 3 of them at the bottom. So all 3 of these will get rid of all but 1 of those. Let's see, everything on the bottom disappeared. I don't even have a fraction anymore. All I have left here is the 3 and that 1 cosine x, 3 cosine x. And then finally, letter F, I have secant x times cotangent x. When I'm not sure where to start, one thing I can try is switching over to sine and cosine. So secant is 1 over cosine. Cotangent is cosine over sine using the quotient identity. Aha, now I have some canceling. The cosines cancel. I'm left here with 1 over sine x. Well, I'm trying to write this as simple as I possibly can. 1 over sine x is just cosecant x. And so that would be the final answer. And then number 7 is a review of factoring from algebra. We will start, as the directions say, by looking for a GCF. So in letter A, I see that I have a 5 in common to both and a couple of x's in common. That leaves me with a 4 and 1x here. And in the second one, I took everybody, so just the 1 would be left there. I could check that by distributing, but here would be the final factored answer. Letter B is what's called a difference of squares. It's a subtraction problem. The first item is a perfect square, x times x. The second item is a perfect square, 6 times 6. And these factor in an a plus b, a minus b format. A and b are the pieces being squared. So this is going to factor x plus 6 times x minus 6. Again, if you FOIL that out, you'll see it comes back to where we started. Letter C, I don't have a GCF. When I see three terms like this, what I think to myself is this was somebody's FOIL problem. The x squared always comes from the f part of the FOIL, which means this must be x and x. The last term here always comes from the L part of the FOIL. So I know that the two numbers sitting here must multiply to 14, which means it's got to either be 1 times 14 or 2 times 7. The middle number is the trickiest. That comes from the O and the I, the outer and the inner part. So whatever two numbers I fill in there for 14 must have something to do with a 5. Well, that makes me think it's got to be the 2 and the 7. I think I can make a 5 out of the 2 and the 7. Let's see, how would that work? It needs to be a negative 5. I'd get a 7x here and a 2x here. So if I make the 7 minus 7, then I'd have negative 7x plus 2x for the other one. There's my negative 5x. Sure enough, negative 14 at the end. And so we've got it. Here's the original FOIL problem. We have factored the polynomial. Letter D, I do have a GCF of 2 that I can pull out. That leaves me x to the 4th minus 16. Now x to the 4th minus 16 keeps going, and I do want to factor completely. X to the 4th minus 16 is a difference of squares, as we already talked about. X to the 4th is x squared times x squared, and 16 is 4 times 4. So it's going to factor in that a plus b, a minus b pattern, x squared plus 4 and x squared minus 4. Again, FOIL that out. You'll see it comes back to what we had. But then this still keeps going. X squared plus 4, nothing I can do with that. Sums of squares do not factor. But x squared minus 4 there at the end, that's another difference of squares. So it's going to factor x plus 2 and x minus 2. X and 2 are the pieces being squared. This is now as far as I can take it. This would be the complete factored form. Letter E is kind of like letter C. I don't have a GCF. I see three terms. So again, I'm thinking in terms of somebody's FOIL problem. 2x squared at the front, that means this has got to be a 2x and an x. The 3 at the back means either this is a 1 and a 3 or a 3 and a 1. It's the only way I can make a 3 in the back there. Let's see, it's a negative 3, so one of these is going to have to be a plus and one of them is going to have to be a negative, and then I'm trying to make a positive 5 at the front. I feel like the only way that's going to happen is if I make a 6x using this 3, a positive 6x, and then a minus 1x using this 1. I think that'll give me that 5x that I want. So it was the top choice that worked. The final answer then is 2x minus 1 times x plus 3. Let's make sure it works out. 2x times x, 2x squared, the minus 1x from the inner, and the plus 6x from the outer. Yes, there's the plus 5x. And minus 3 for the last, and so we've got it. Letter F looks similar, although it does start with a GCF. I do have a common factor of 2, leaving me with x squared minus 8x plus 15. And then we're wondering if that other part keeps going. If it does, it's got 3 terms, so it would have to be a FOIL problem. Let's see, it's got to be x and x for the front. 15, I mean, it's either 1 times 15 or 3 times 5. I got to make an 8 in the middle, so it's bound to be the 3 and the 5. And then wouldn't they both need to be negative? Yes, negative 3x and negative 5x makes negative 8x, and negative 3 times negative 5 makes positive 15. And so we've got it. Here's the final factored form.